Hello everyone. For this section, we're going to discuss qualitatively how the pressure of the gas changes with temperature, provided the volume of the gas remains constant. Now, for a start, let's observe the number of collisions between the molecules and the wall of this chamber per unit area. Also observe the number of collisions between the molecules and the walls per unit time, and also observe the average speed at which the molecules collide with the walls. Now, the first thing I'm going to do is I'm going to decrease the temperature. Now, when I decrease the temperature, what is the very first thing you notice about the average speed of the molecules? Now, the very first thing you see is that the average speed of the molecules actually decreases. So when the average speed of the molecules decreases, the force at which the molecules collide with the wall also decreases, right? Now think along the line, when you run at lower speed and you hit an object, you hit it with a smaller force, right? Now I'm going to isolate a small section of this wall, and also notice that when I isolate a small section of this wall, you will see that the number of collisions between the molecules and the wall per unit area also decreases, and the number of collisions between the molecules and the wall per unit time also decreases, and therefore the pressure of the gas decreases. Hence, from here we can say that as the temperature decreases, the pressure of the gas decreases, provided the volume remains constant. Next, how about I were to increase the temperature? So I'm going to increase the temperature. Observe the molecular behavior. And what's the very first thing that you observe? The very first thing that you observe is that the average speed of the molecules increases, and therefore the force at which the molecules collide with the wall also increases. So think again, if you run at a higher speed and you hit the wall with a larger force, right? And if I were to isolate a small area of the wall, also notice that the number of collisions per unit area increases. The number of collisions between the molecules and the wall per unit area increases. And the number of collisions between the molecules and the wall per unit time also increases. And therefore, the pressure of the gas increases. Hence, when the temperature increases, the pressure of the gas increases, provided the volume remains constant.